Let's take a look at how Spec-Mode in Kiro differs from traditional vibe coding with an AI coding assistant. In this demo, I'll show an example of building a full-stack application with Kiro from initial requirements to fully tested production quality software in just 6 hours. But don't worry, we'll be compressing the 6 hours of coding into a bite-sized 10-minute demo. On the top left of the screen, you'll see a running time, showing the real time that has elapsed since we started. For this demo, I've invited my product owner to sit through this coding session with me. He will act as the functional and domain expert, providing the requirements and feedback from a user's perspective, while I will act as the engineer who pilots the coding session using the Kiro IDE in Spec-Mode. It's okay to begin with a somewhat vague requirement, because with spec-driven development in Kiro, as you'll see, we'll be able to adapt to requirement changes in a structured way. We will dynamically refine our requirements and design specs as well as task plans for each change in scope or requirements. In fact, we embrace such changes because it's natural for users to follow up with more and more detailed requirements after seeing each iteration of the software being built. To help you follow along more easily, let me give you a glimpse of how my product owner stated the initial requirements. However, this is what he really expected in his mind: a GUI-based file chunking utility with which he can split any large file into smaller equal chunks by dragging and dropping the file through a web interface. He wants to be able to choose between two file chunking methods, either by specifying the number of chunks to split the file into, for example, to split a file into 5 equal chunks, or the maximum size per chunk, such as splitting a file into chunks of 10 megabytes each. He also wants to be able to download each resultant chunk individually, or all chunks together in a single zip file. Let's start by letting my product owner, or PO, specify the requirements to build a file chunking application, in his own words. With this initial input, Kiro in Spec-Mode will begin by creating a requirements document in Markdown format. Kiro creates a complete set of user stories and their associated acceptance criteria. The acceptance criteria are structured using EARS, or Easy Approach to Requirement Syntax notation. I ask my PO to review and provide feedback about the user stories, which we can either edit manually or get Kiro to make changes with further prompts. Kiro has created 7 user stories initially. After a quick scan through the user stories and acceptance criteria, my PO is happy with them, so I ask Kiro to proceed with the next phase. This instructs Kiro to create a design document based on the requirements, detailing the technical architecture, sequence diagrams, and implementation considerations. Upon looking through the design, my PO immediately spots something wrong. Kiro has proposed a CLI, or command line interface, for the application, whereas he is expecting a GUI, or graphical user interface. We double-check the requirements to confirm that it hasn't been explicitly stated to have a GUI. So we prompt for Kiro to make it a GUI-based application, allowing the user to drag and drop any file that they want to process. Kiro then proceeds to update the design automatically to cater for a web UI. As we review the design further, we see that in just over 5 minutes, Kiro has also documented detailed error handling and testing strategy, including unit, integration, and performance tests. After thinking through the proposed design, my PO has several questions in his mind. I ask him to park these thoughts in a to-do file and we'll tackle them as we go along. For example, how is the file sent to the backend after we've selected the file on the front end? Although the design states HTTP/WebSocket, it is not detailed enough, so we ask Kiro about it. The beauty about asking clarifying questions is, each time we do that, Kiro updates the design with more details, so the design document becomes more comprehensive and complete. In this case, Kiro has added enough details about the file transfer mechanism to satisfy my PO. So we mark that to-do as done. Next, my PO has a new requirement, and we tell that to Kiro, that the file chunking utility should be able to handle large files greater than 1 terabyte in size. Kiro adds this new requirement in the requirements document and updates the design document to cater for it as well. With spec-driven development, it is easy to allow for changes in requirements and scope, as the specs are incrementally updated with every change. Next, my PO asks a question about how the file size metadata is conveyed to the backend before the entire file contents are sent across. This clarifying question sparks Kiro to update the design document with a section on the file size determination strategy, explaining what happens during and after file upload, including validation checks. Once again, asking questions result in Kiro updating the design document to become more detailed. With that, my PO is ready to accept the design, and I instruct Kiro to move on with the next phase, to create an implementation task plan. Kiro then documents a series of tasks required to build our software end-to-end. Each task is traceable to specific requirements for full traceability. We review the task plan together, and once satisfied, I instruct Kiro to proceed with code implementation according to the task plan. At this point, we are barely 22 minutes into the session. Note that when Kiro is executing each task, it will also create unit tests for every task, and these unit tests must all pass for the task to be considered complete. Here we have a task with 2 out of 24 unit tests failing. Kiro will automatically debug the code and attempt to fix the issues in order to pass all tests. As it does so, we can observe through the terminal logs the number of failed tests burning down, from 2 failed to 1 failed, then to all tests passed. At this point, we're about 33 minutes into the session with our first task complete. We now sit back and wait as Kiro proceeds to code and implement all the other tasks, from the back-end module to the front end. After the front-end code is complete, it moves on to other areas like comprehensive error handling and validations to make the application more resilient. And after that, it goes on to optimize for performance. That includes adding monitoring and logging for performance metrics. By the time Kiro has completed all implementation tasks, we're about 3 hours into the session. I then start up the application for an initial test to verify what's built. Immediately, my PO spots a minor UX issue. The blue font color is difficult to read when contrasted against the dark background, so we note this down in our to-do list and proceed on with our exploratory testing. I test the flow of selecting a file and uploading it and run into an issue. The uploading seems to be hanging. When I examine the application logs, I see errors appearing in the logs. I copy the error logs and paste them into Kiro, and prompt for Kiro to debug the issue. Kiro analyzes the logs and attempts to identify the issue. Once it has found the issue, it automatically fixes the bug. After that, I resume my testing of the file chunking flow, starting with selecting and uploading the file again. This time, the upload looks to be working successfully. I double-check the logs to make sure there are no errors in them. I then continue testing by configuring the chunking parameters and checking that it is splitting the selected file into chunks as expected. I also check that I can download the consolidated zip file containing all chunks and randomly test the download of a few individual chunks. Next, I make sure that I can reset the application state by cleaning up the file chunks. The end-to-end flow seems to be working fine now. So we start tackling minor UX issues such as the font color. Kiro tries to use a different font color, but it has made it even harder to read. I prompt it explicitly with the color I want, and this time my PO is satisfied with the outcome. I retest the entire flow again, asking my PO to focus on uncovering any other UX issues. He spots an issue with the post-chunking buttons on screen. The buttons to download the chunks are gray in color, making them look disabled. I then prompt for Kiro to change the color of those buttons so that they do not appear disabled. After Kiro has fixed the color, we go on to test if the application can handle chunking from multiple input files, including large files greater than 2 gigabytes in size efficiently. After loading multiple files for chunking, we confirm that the application is allowing us to toggle between the input files for chunking. We are approaching the 6-hour mark now, and everything looks to be in working order. I then decide to further automate UI testing in the browser, asking Kiro to create automatic live verification tests by simulating the end-to-end flow of a user, performing file chunking in the front-end screen. Kiro builds the automated live verification tests using Playwright and provides a detailed documentation for it, including a flow diagram in Mermaid format to explain the live verification workflow. With that, I can reduce manual toil for testing through automated browser tests for live verification. The test results can be easily checked from Playwright's report view. The report shows that the application was successfully tested against various browsers such as Chrome, Firefox, Microsoft Edge, and their mobile equivalents. Screenshots are also captured as test artifacts for every step taken during the automated browser tests, so I have well-documented test results readily available to end users for sign-off. In all, we spent about 6 hours in total to build this application to a production-ready state. 3 hours to complete the initial build, then another 3 hours to test, debug, and make minor enhancements to the application. In a traditional build without a spec-driven AI coding assistant like Kiro, we would probably have required 2 weeks to reach the same level of quality and completeness. That's the power of spec-driven development, using Kiro.